Okay, so in this video, I'm just going to do one more reasoning question and then an example like you might see on your practice, and then some cool examples of domain and range. So um, this first example, it says the graph below represents the height of a ball over the interval 0 and over the interval between 0 and 8 seconds. After how many seconds was the ball 12 feet off the ground? Explain your answer. So this is just looking at the graph. I'm going to look for 12 feet. 12 feet is, let's see, it's going to be 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. So 12 is all the way at the top. And if you see, that is not in our range at all because my graph only goes up to 11. So I can actually type in here, the ball will never reach 12 feet because it is not in the range of the function. So it says, what does your answer indicate about the range of this function? Well, the range of this function is the lowest it'll ever be is 0, and the highest it'll ever be is 11, and 12 is not in that range there. So that's kind of why it'll never reach 12 feet above the ground. Awesome. So that's just another reasoning question. Some might ask you, what is a domain? It's from, they kind of gave you that there, so they might ask you range or whatever, or just ask you questions about how long will it take, or etc. This next example is just like one you might see on your practice, and it'll ask you what the domain and range is. And this example is called an example of a discontinuous function, and that just means it doesn't continue. So it's broken up. This one up here would be that would be a continuous function because there's no breaks in it. This graph would be a discontinuous function because that's not continuous as it goes on. So if we're looking at the domain of this, we're just going to look at the values where the points are. So for example, I'm looking at the x value, so my domain, and since it's not continuous and there's only a specific point, I'm going to have to use set notation or the curly brackets. So if you look at this point, there's a domain of 1, 2, 3, 4, 5, and 6. So the domain for this is 1, 2, 3, 4, 5, and 6. And yes, I have to list out all those numbers because I don't have numbers in between 1 and 2. For example, 1.5 is not in my domain. If I look at where 1.5 is, that's like right here, and there's no point right there. So that's kind of why I have to use set notation if I'm looking at a discontinuous function. And then the range would be very similar. Now I'm only looking at my y values. So the y value would be 6, 3, 2, 1, 0, and -1. So it's better kind of to list them as like a number line, so going from smallest to largest. So -1, 0, 1, 2, 3, and 6 is my range. So that's my domain and range, and that's how I'd have to list them if I was putting my answer. So in your practice, you're going to see some that look like this. So just look at the points x values and the points y values, and those are the only numbers you're going to have in your answers. It won't be continuous like this one was up here. So you won't have a range, you'll have just specific numbers. Okay. Some other challenging questions. So this is kind of cool to look at is what domain and range looks like for certain functions. So we just took a ton of time studying exponential functions. So I want to kind of look at what the domain and range for those are. And I'm going to do that by looking at Desmos. So I'm going to go to Desmos and type in y equals 2 to the x. So I got y equals 2 to the x. And I want to look at my domain and range for this. So the nice thing about Desmos is you can scroll out far out as you want, and you can kind of look at what happens for the graph. So for that x, I want to see how far left it's going to go. So I could, drag this as far left and I still see that red line. And I could also, use my table feature in here to see if I'll always have a y value for some x value. So I could type in negative 100 million. Negative 100 or negative 1,000, and it's going to give me just a really, really small number. But if you think about it in terms of this, 2 to the x will never give me 0. So it'll never go below that 0 value. And we'll kind of talk about that when we talk about range. But anyways, you can keep going forever and ever, and you're always going to get a really small number. I know that when I did this before, it had, if you type in a number bigger than that, it'll say 0. That's not necessarily true. It's Desmos approximating. Because if you typed in on your calculator, I wonder if it'll do it on here for me, 2 to the negative 100,000. It won't do it on here for me. But if you typed it in your calculator, it's going to give you a really small number, because 2 to anything will never give you a negative number or a 0. So the range for this, because it's going to keep going all the way to the left, would be negative infinity to positive infinity, because it's going to go far right as well. This will never, if you go back to the original, it'll go up forever and it'll never stop. You can type in as big a number as you want, it'll go up to infinity. So I can type in, if Desmos can't go that high, I can type in a big number like 1,000 and it'll always go up. I can always plug in a number. I can do 2 to the millionth power and it'll still give me a really, really big number, but it'll still be a number. So that's going to go negative infinity, positive infinity. This is where I was kind of talking about that bracket notation, because, and I made a mistake here, these can't be equal to, because I can never actually get to infinity. So I'm going to have to keep these as less than and greater than sign. So I can also write it in this notation, negative infinity to infinity. And I use the soft brackets, the parentheses, to indicate that it's not equal to, like I did in the interval notation. So then the range is where it gets interesting, because I'm looking at where is the lowest point and where is the highest point. So if you look, you can get really, really close to this, and it looks like it's on that 0 line, but it never will be. So if you type in on your calculator 2 to the a millionth power, or to the negative a millionth power, you'll never get 0. It'll always be a really, really small number. So it'll always be a decimal number. So the range for this is going to be actually 0, because it'll never get to 0. So that's where that's where you can kind of use the notation y is greater than and not equal to, because it'll never actually be 0. And then infinity. So I would use soft bracket 0 to infinity here. So this is just kind of where things get a little confusing, and so I just kind of wanted to show you those examples. So that's domain and range. It's there for that function. I would more so worry about the examples we just talked about. The difference between this, so now I'm going to look at this function. This is a quadratic function, so I'm going to expect a parabola. So if I do y equals x squared plus 3x plus 2, it looks like that equation. So I can, again, look at my lowest point and my highest point and fire from left to right. So if you look, I can go forever and ever one way and I'll still get a number. It's just going to keep going up and up and up. I can always plug in a number for x, and I should always get an output. So my domain, and this is where I wanted to make sure, we want to look only over the interval negative 2 to 2. So this is where I might use that table feature in Desmos or in your graphing calculator. Just make sure you're looking at this window. So from negative 2 to 2, that's my domain. What is the range? So domain, I am restricting it to negative 2 to 2. And my range for that is, so the y values are going to be from 0 to 12. So my range is from 0, and my highest point is 12. Okay, so that's kind of domain and range. You can write it as, and this would be equal to, so I'm going to use hard brackets, -2 to 2, and then 0 to 12. So I could write it either way. And so then if I don't restrict that domain, so if I just look at the graph overall and I don't care about the interval I'm looking at, I can scroll in and out, up and down, and the lowest point will be here for my range, so negative a quarter. So I can say that my range, and sometimes I like to do the range first, so I can do -1/4 or -0.25, and we're at my highest point, it's going to go forever, so it's actually just going to be infinity. And so this is where you got to be careful with your signs. I can never actually get to infinity, so it's just going to be a less than sign and not equal to. So if I were to write it in bracket notation, it would look like -1/4 to infinity with a parenthesis. So that would be a hard bracket here and a soft bracket there, saying I can't have it equal to infinity, but I can have it equal to -1 or -1/4. So then my domain for this is easy. It's just -infinity to positive infinity, which means I can plug in any x value I want and I should be able to get out a y value. So I think that's the last one I'm going to show you. I don't want to confuse you too much with this one down here, but those are just really the main ideas. These were definitely more tricky, and the graphs are a little more complex, so it just takes a minute to kind of understand that, but you'll definitely have more practice with that as you get into Algebra 2. So the main idea of domain and range is just that you understand domain is input, range is output, domain means all your x values, domain or range means all your y values. So thanks for watching.